Now, in the previous lesson, we talked a little bit about the memory layout and how TVM is instantiated. Now, let's dive into how message is processed and what really is a transaction. To make any change to the state of a contract, it needs to receive a single message. It's called an incoming message. There are two kinds of incoming messages that could arrive to a contract: external and internal ones. So let's take a look. External message is really just a string of data that comes from nowhere from the perspective of a blockchain. This data is not authenticated by itself. It doesn't have any money attached to it in form of ton coins. And it can really contain anything that the author of a contract wants. And it's the job of a contract to make sense of this data and parse it right inside its code. The internal messages are those that are sent by contracts to other contracts. And these messages have a little bit more rich structure. First of all, the internal messages can carry the balances. And when the contract sends the message to another contract, they can attach any amount of coins to it. Second, those messages are securely authenticated by the address of a sending contract. And the entire architecture of Ton guarantees the contracts that this address of a sender is correct. And this is very important for authentication of the internal messages that we will talk about in the later lessons. Once the contract received the message, they could have two separate handlers for internal and external ones. And both kinds of messages will have the arbitrary payload data that is designed by the author of a contract. If the contract wants to process different kinds of messages, then it will use something that we call opcodes. These are operation codes. It's simply a convention to put a prefix of 4 bytes in the custom data in the message to indicate the type of the operation that the contract should support. So you will find in the standard wallet implementations or in token implementations, you will find various opcodes that are usually computed as either sequence numbers like operation 1, 2, 3, etc., or as a CRC32 code of a description of the message interface. This helps you to extend the contracts with various features without having those opcodes clashing. But this is merely convention. From the perspective of Ton blockchain and from TVM, this is just a piece of data in a message that the contract decides to use to discriminate between different types of messages. So what is a transaction? Transaction is a complex of changes to the state of the contract. So the message is not a transaction, it's just an input to a transaction. And what transaction does is it changes the state and creates, as a result of the TVM operation, creates a new state for the contract and a list of outgoing actions. And to come to this result, there are 5 phases that the transaction goes through. First phase is called storage phase. This is the phase when the blockchain charges the contract for all the rent that it owes for its existence. And the rent is computed as a price per bit per second. And in between transactions, all of these seconds and all of these bits are multiplied. And before the transaction begins execution, this is when the blockchain withholds from the balance of the contract the necessary amount of rent. If at this point the contract runs out of money, then the rest of the execution aborts and the contract is frozen. So this means that if you hit the contract that is already past its rent, then it will not process any more data and it will just sit there in the idle state and wait till it's unfrozen by its owner and its balance is replenished. So once the storage phase is over and the contract has successfully reduced its balance by the rent, here comes the second phase, which is called credit phase. This is where the coins attached to an incoming message get credited to the contract. Obviously, this doesn't apply to external messages because external messages are plain data and they cannot have any coins in them. But the internal messages mostly always carry the coins and these get credited to the balance. So this is pretty simple. Now comes the third phase, which is called computation phase. This is where your program comes to life. The TVM executes the code and verifies each operation and also keeps track of gas usage. So every operation takes some amount of gas from its limit, and you as a program designer, you could limit the gas usage how you want. So for instance, you can limit it to the amount of coins that just arrived to your balance, which means that all the gas will be paid by whoever sent you the message. Or you could decide to increase this limit. Let's say you verified that the message came from a verified source, and then you could say, okay, I increase my gas limit to the entire balance of my contract, and then I'm allowed to spend as much money as I want. And then it's your job as a developer to make sure that this code is not running out of money. And as TVM executes the code and charges the gas costs along the way, it produces output actions. And if you didn't run out of money and didn't violate the rules of TVM, so for instance, didn't do the invalid arithmetic operation, then TVM finishes execution, and you have a list of actions. And here comes the fourth phase, called action phase. Most important action in this phase is the new state of a contract. So your contract may, at the end of the execution or at any intermediate step, create new state and new storage for itself, and this will be recorded after successful execution of a contract. But there are other actions in the list and in this action phase, and those actions are outgoing messages. Those are the messages that the contract communicated to other contracts. So for instance, if your contract is a wallet contract, then you would almost always have output actions that would send money and instructions to some other contracts. For instance, if you want to just transfer coins to another wallet, then there would be an outgoing message that says, please send this amount of coins to that destination address. And the goal of the fourth action phase is to process those actions and record the new state and route the messages. And finally, the fifth phase is called the bounce phase. This happens if the contract failed and the incoming message had a flag saying, I'm a bounceable message. It means that at this phase, if there's any failure and there's any money left from the incoming message, then the contract would create the outgoing message back to the sender to bounce the money back. This is a safety feature that allows people to get most of the funds back in case there is any error or any failure inside the contract. And you as a developer could use the bouncing as a feature, so it's not just an emergency situation. It could be a feature of your contract. So if some conditions are not met, the user's incoming message would be bounced back and they will get their money returned. That's the summary of all the action phases. Let's go through them once again. The contract receives an incoming message that could be internal or external. Internal messages can carry money and can be authenticated by the address of the sending contract, while external messages are not authenticated by themselves at all, and it's the job of a contract to create the authentication. For instance, check a signature that could be stored there. And then the execution of transaction goes through 5 stages. The storage phase to charge the rent, the credit phase when the incoming coins get credited to the balance, computation phase where your code gets executed, action phase when the storage is updated and outgoing messages are routed, and finally the bounce phase when the contract deals with the failures and sends back the coins to the sender. So that's the overview of the messages and transactions. Thank you.